Good morning, one and all. I am Dr. Ramya Swetha, Assistant Professor, Department of Civil Engineering from Institute of Aeronautical Engineering. Today, our topic is Module 2, Mechanical Modification. Based on this mechanical modification, today we are discussing about a question bank and what are the tutorial questions which we are there and how to explain them in our examination point of view. As per examination point of view, how we understand the question, according to that question, how to write it. So briefly I am explaining according to the based on the given marks, please elaborate it and write the answers as per the question. The understanding of the question is very important in any sort of examination. So in this, explain the process. So we know mechanical modification. So we are going to alter the soil properties as per the requirement of construction work. So in this alteration process, different subcategories we are categorized. The categories are there. In that, mechanical modification is one sort of modification for soil, altering their properties and it desired properties for getting the desired properties of the soil as per the requirement of the project work. So in that, one of the important category is the mechanical modification. In that module, now we understand what are the various types of questions. There is a chance of what are the types of various questions and how we are going to answer all those questions. It depends upon the type of the question and how we understand the mechanical modification. So briefly in this, based on the mechanical modification, we have different types of techniques for the particular properties and also the type of the soil. We choose the technique based on the type of the soil and what type of desired property we are going to alter. We are going to modify which type of property. So based on that, we have to understand which type of modification is suitable for which type of the soil and also the property. So based on this, we are understanding the mechanical modification under these various techniques involved in this mechanical modification. So now move on to the tutorial question banks. Explain the process and benefits of soil compaction as a mechanical ground modification technique. So here they are asking mechanical ground modification technique, benefit and also the process and the benefits of the soil compaction. This compaction is the mechanical ground modification technique. So they are asking in detail. It may ask like this, explain the process and benefits of soil modification also. The thing is same. Here now we understand and explain and process and benefits means first we have to explain about the soil compaction and after that we are going to explain the process. After that the benefits which are involved in the soil compaction. So according to the marks, how many marks we are getting for this also important. But for any, for any type of question, first understanding the terminology which are involved in that particular question to answer the question. So in this, soil compaction it is a mechanical process. So here they asked about process. That's why we are explaining this is the mechanical process. Already we know because of the question it is mentioned soil compaction as mechanical modification. So like that we are going to answer. So once we understand the question clearly, it gives some of the answers very clearly for us. So in this, explain the process and benefits of soil compaction as mechanical ground technique. This now the answer is soil compaction is a mechanical process that increases the density of soil by reducing air gaps between the soil particles, resulting in more stable and durable soil structure. So in this, the important terminology is soil particles and stability, durable of soil structure, stability. These are the terminology. For any marks, the given question is for any mark, for 2 marks or 3 marks. This terminology is important. After that, that explanation is depends upon the number of marks. Here, it is a mechanical process and it increases the density of the soil. So, which type of soil properties it is affects? Which type of soil properties are going to alter? That is density. As per this question, that is density by how it is going to reduce. So, using this compaction technique, using the technique. So, in generalized, we will understand, not in compaction point of view, any type of technique which may mention how we are going to answer the question. So, consider it is as an example based on the soil modification. Whatever the technique it is based on the technique. Which type of technique we are using. And what type of soil modification is done. Whether it is increase or decrease the property, whatever it may be, soil modification. Property. Based on which type of property it is going to modify. And how it is reduces means density of the soil by reducing air gaps between the soil particles. So what this particular technique is do? What it will do? What that particular technique is going to do? Here, soil compaction, it is a mechanical process. As per the part of the explaining, we are writing like this, that increases the density. This soil compaction is a technique and this soil modification is the density of the soil. What it will do means air gaps between the soil particles. If you will get the density, improving density means we are reducing the particles using this technique. And final result, what is the result we will get is that it is more stable and durable structure. So it means now we are going to understand using based on the technique, which type of technique we are using, what kind of soil property is going to modified, modification, and later how it will work. What we get is the result. So like this we are understanding any type of the technique for these modifications. So it is the now soil compaction. It increases the density of the soil. What will happen? Reducing air gaps between the soil particles. What is the result? More stable and durable in soil structure. This is the soil compaction in simple words. These are the technical terms which we are used as per the technology which is given by the question, which is given in question. Now the process, that is nothing but the step-by-step procedure or whatever it may be. Now the process, site preparation, layer placement, compaction, quality control, these are the process. These are the processes which are involved in this. We may explain in more also. Just generally I am telling in soil compaction point of view, in any technique, site preparation, what we will do. And here it is compaction means we are doing the compaction, or otherwise which kind of equipment we are using, what it will do, how it is installation is required, how we are installing the technique. So and finally what we'll get. So these are the process which we follow for any kind of technique for getting the desired soil property. So in this, the first one is site preparation. In that, clearing and grading is the important parameter as per soil compaction. So we are remove vegetation, any kind of obstructions from the site. The next one is moisture content adjustment. Ensure that soil has optimal moisture content for compaction. This is for especially for compaction, not for any other techniques. So like that we have to ensure which type of technique requires the what type of procedure. So here the moisture content is the important parameter for the soil compaction. This is important terminology which we used. So ensure that soil has optimal moisture content for compaction. If necessary, add water or dry the soil. It depends. Sometimes it may very dry. We are going to add the water for get moisture content adjustment. Sometimes it may be wet. We are going to do the some dryness drying test, whatever implementing, we achieve the desired moisture level. Now layer placement. In compaction, the next process is the layer placement. So soil layering. So spread soil in thin or uniform layers, usually 15 to 30 mm thick, to ensure even compaction. For getting even compaction is also one of the terminology which we use in compaction, soil compaction. So like that we have to understand. In other technique, they have their own terminology. In compaction, equipment selection. Now, for compaction, soil compaction, simply in these also different types of compactions are there. Which type of compaction is suitable is depends upon the ground conditions or desired properties what will require for the construction work. So in this, equipment selection is depends. So choose proper compaction equipment based on the soil type and the project requirements. So common equipment includes rollers, vibratory plates and rammers. Compaction process. So now we are applying based on the equipment, the process is depends. It depends upon the, based on the equipment, it depends. So now apply repeated passes with selected equipment. The selection of equipment is important. It is depends upon the which type and project requirements. So this selected equipment to densify the soil. Each layer is compacted until the desired density and strength are achieved. So what are the desired properties achieved? We are going to conduct the process. Now site we prepared as per the compaction requirements. We are involved the steps. Other techniques, it has their own kind of steps because equipment is different. It may be involved different types also, and also which type is which type is adopted for which kind of equipment. It depends. Now quality control. Testing. Perform field tests such as standard Procurator test or modified Procurator test to measure soil density and moisture content. Ensure the compacted soil meet the project specifications. So we are testing after completion of everything whether we get the desired properties or not as per the project specifications. Desired properties. So like this we have to explain the soil compaction as a mechanical ground modification technique. And also any other technique, it depends upon the how it will ask. Now in this, what are the benefits of the soil compaction? In soil compaction, benefits of the soil compaction: increased load bearing capacity, reduced settlement, improved shear strength, lower the permeability and enhance durability. These are the benefits which we will get in our soil compaction. So increased load bearing capacity. So compacted soil can support greater structural loads, reducing the need for deep foundation and lowering the construction cost. So this is the one of the benefit using the techniques. So this soil compaction, each technique has their own kind of benefits. Stability point of view, water moisture content point of view, depends upon the desired properties. So each technique has their own kind of benefits. Here we are talking about the soil compaction. Compacted soil can support greater structural loads, reduce the need for deep foundation and lowering the construction cost. Now reduced settlement. Proper compaction minimizes the risk of excessive settlement, which can lead to structural damage and uneven surface. So here proper compaction minimizes the risk of excessive settlement, which means structural, it is reduce uneven surfaces, it is going to reduce. Now improved shear strength. Compaction increases soil shear strength, enhancing the slope stability and resistance to the failure. So in lower permeability, compacted soil has fewer voids, reducing water infiltration and the risk of erosion and soil weakening. These are the things which are going to involve in our infiltration and the risk of the erosion and soil weakening. And also one more important benefit from soil compaction is enhanced durability. So in compacted soil is less susceptible to weathering and environmental degradation and extending the lifespan of the structure. So these are the benefits which we observe. So like this we have to understand the question. We are going to explain detail about the question. Now, and also the applications where we are going to apply typically foundation preparation, road construction, embankment and dams, landfills. So for foundation, what kind of application it means? It stabilizes, creating stable base for the buildings, roads and other structure. In road construction, forming subgrades and base layers for pavement systems. In embankments and dams, ensuring stability and preventing seepage in earth structures. In landfills, compacting waste materials to maximize the capacity and stability. So now move on to the other kind of, that is dynamic compaction. Previously we understand only soil compaction in the different methods. Here that is one more method. There is a chance to ask like this. So previously explain the process here. Describe the dynamic method and its application. What are the advantages and limitations of this technique? So in this dynamic compaction, now we are confined to the dynamic compaction. In previously that is different. So we have to understand the question. Previous question is more generalized when compared to this dynamic compaction. In this dynamic compaction is a ground improvement technique that involves dropping a heavy weight repeatedly onto the soil surface to densify the loose granular soils. The energy imparted by falling weight compacts the soil to greater depths, improving its load bearing capacity and stability. So we have to understand the dynamic compaction. You have to write 2 to 3 sentences regarding that technique, whatever it may be. Whether it is static compaction, other kind of technique, whatever it may be, first we have to understand. And according to the marks, we have to explain this process also. So site preparation, compaction procedure, testing and control, quality control. So in this site preparation, we are remove the surface obstructions and level the ground. That is the first thing we do in any kind of technique generally. So now weight selection, it depends upon the requirements. It depends upon the requirement. Choose appropriate weight. We are choose the appropriate weight based on the requirements. And drop height from based on the soil type and project requirements. In this mentioning of weights is important parameter for this technique. So similarly, any kind of technique has their own kind of parameters should be mentioned. So this is the one kind, this is important, how the ranges is important as per the dynamic compaction. Now move on to the procedure, grid pattern and dropping weight. So here in dynamic compaction, the defined grid pattern from weight drops ensure even coverage of the area. Why? Because of the even coverage of the area. This grid pattern of the weight is the technical terminology which we are used for this question. These are the technical words. So like this we are going to understand this one. So in this and coverage the area, the dropping weight, use a crane lift and drop the weight onto the soil at predetermined points on the grid. The weight is dropped multiple times at each point to achieve the desired level of compaction. Now explain the procedure of which type of technique it is. Now testing and quality control, field testing and monitoring. So conduct tests such as standard penetration test STP or cone penetration test CPT. SPT or CPT before and after compaction to assess the improvements in the soil properties. Before also we are conducting the same field tests, and after also we are conducting those tests because for understanding what type of soil properties are going to improve to assess that is the important parameter. So to assess and all these the important thing in our dynamic compaction. Any kind of technique, what we are assessing and which type of tests we are conducting, name of the tests or the terminology which we used. It depends upon the which type of technique. Now, monitoring. Monitor the depth and extent of the compaction to ensure uniformity and the effectiveness. So like this, we are understanding this. And one more thing is what are the advantages and limitations. And also the where and its applications. So it is maybe in less marks, 2 marks, no need of all these things. Simply we are describing this dynamic compaction. What are the applications? But here I enlarged somewhat because understanding other techniques also. So in place of this, we may use any kind of technique, site preparation, and which type of procedure for that particular technique. What are the terminology, important words we are using, we have to incorporate in our examination. After what kind of test for the quality control we are conducting for that particular technique. Now move on to the applications. It depends upon the which type we are using, which type of technique. So applications, land reclamation, foundations, road and railway abutments, airport runways are the major applications for this dynamic compaction. This is for land reclamation, improving the reclaimed land for the construction. For foundation, densifying the soils for industrial facilities, warehouses and other heavy structures. For heavy structures, we are choose these kind of dynamic compaction. Heavy structures. Road and railway embankments, stabilizing the loose soils for transportation infrastructure. These are the applications for this dynamic compaction. Airport runways, preparing stable bases for runways and taxiways. What are the advantages? Cost effective, and this for the more depths, whenever the other techniques are not effective that much, like static compaction, this dynamic compaction is used for the deep compaction. Versatility, rapid improvement, these are the some of the advantages which may observe in our dynamic compaction. Cost effective, relatively low cost method for improving large areas of loose soils in that particular condition. The condition is important. Each and every technique has their own kind of conditions, where and what type of soil. And in deep compaction, effective for compacting soils to significant depths. So whenever the depth is more, this kind of compaction is suitable. It is suitable for wide range for the granular, including sand and gravels also. Some of the techniques, they are confined only single type, only one kind, only Koju soils, only non-Koju, like that. But coming to this type of technique, this dynamic compaction technique used for granular soils, including sands and gravels. Rapid improvement, can achieve significant soil improvement in short period. In less time, we are observing the modifications of the soil properties. We observe soil modification within the less time because of this dynamic compaction technique used for the modifications of the soil in ground modification. Limitations. In this, noise and vibration. It is also some limitations, that is noise and vibration, surface disturbance, limited effectiveness in Koju soils, environmental concerns. These are the some of the limitations are there in this technique. Every technique has their own kind of limitations. In this, noise and vibration generates high level of noise, creates so much noise. Why? Because we are dropping from high depth up to 10 meters. We are dropping the equipment from the high depth, that creates some noise and ground vibrations also. Nearby some very weak structures or any kind of is there, it is going to affect. So such type of disadvantage is there in our dynamic compaction. In surface disturbance creates craters and surface irregularities that requires additional grading and leveling. So because of this dynamic nature, so the leveling is oddly getting, so it creates so much disturbance, so it requires additional grading to getting the surface level. In limited effectiveness in Koju soils, whenever we are using also, but it is less effective in compacting fine grained and Koju soils such as clay and silts. It is not that much effective. It means we are not getting the desired soil properties for these fine grained and Koju soils when compared to the sand and gravel. So compared to the other types of soils, they are not much effective for these fine grained and Koju soils and such type of clay and silts. It is not expected, we are not getting the desired properties. In environmental concerns, potential for environmental impacts due to the noise, dust and vibrations. So because of the high depth we are using, so it creates some noise and also dust and vibrations. It is one of the environmental concerns which we are understanding for this dynamic compaction. Every technique has their own applications, advantages with some disadvantages along with some concerns. So like this we have to analyze what type of technique, which type of soil we are using, what kind of modification we are getting, how effectively we are reaching. These are the parameters we are understanding for each and every technique. Now another type of question, what is soil replacement and how it is performed? What are the discussed advantages and disadvantages? This soil replacement is also known as soil exchange or removal of the and replacement. In soil replacement, sometimes it is we are going to replace the soil, and sometimes we completely exchange, we are remove the soil in that particular, whether it is partially or completely, it depends upon the soil type and what are the required properties. So in this is a ground modification technique that involves excavating poor quality of soil. We are excavating the poor quality of soil and replacing it with more suitable material to improve load bearing capacity, stability and also other geotechnical properties to get the required properties, desired properties of soil for the construction. We are choose this soil reinforcement replacement method. In this, site investigation, excavation, replacement and quality control. Previously for the technique, site investigation is the common parameter for any kind of technique most of the times. And next one is compaction. Here excavation. It depends upon the type. The process, it depends upon the type. So here soil investigation, we are conducting the soil test for understanding the properties of the soil and to assess the and extent of unsuitable soil. And material selection, we are going to choose replacement material based on the required construction work, what desired properties of the construction work or project. So choose suitable replacement material as granular soil, granular or engineering fill. So now excavation. Now we are going to excavate that poor soil. So remove the unsuitable soil to required depth using the excavation equipment like backhoes, excavators. Based on that, it depends upon the situation, scenario of the replacement and removal, how we are removal type of the soil and everything. Now replacement, we are replacing placement of the reinforcement material. Place the selected replacement materials in layers. So we have done the compaction. So not at a time we are not going to replace the soil. Layers by layers, selecting layers and we are replacing in terms of layers. After that compact each layer using the appropriate compaction equipment to achieve the strength, desired density and strength, whatever the desired properties. We may simply write desired properties also. If is particular means it good. I mean density, strength like that. If it is particular means it's very good. Otherwise no issue, desired properties also we may write. In quality control, after conducting testing and monitoring, perform field test to ensure the compacted replacement material meets the project specifications. Whether it is reach or not, we are going to specify. Now we are going to monitor the process to ensure uniformity and consistency in the replaced soil. So we are understanding. Now, advantages of the soil replacement. Improved load bearing capacity, reduced settlement, enhanced stability versus versatility is the sum of the advantages which we observe in our soil reinforcement. So replacing the weak soil with stronger material enhances the soil's ability to support the structural load. And reduced settlement minimizes the risk of excessive settlement, which can use structural damage and uneven surfaces. Enhanced stability provides a stable base for construction, reducing the risk of the soil failure and instability. Versatility applicable to various soil types and construction projects, including foundation, roads, and embankments. These are the some of the advantages of soil replacement. Coming to the disadvantages of soil replacement, high cost. It is high cost because we are completely replacing the soil, whatever it is there, that weak soil, we are including another material. So material may be expensive and the process is involved. So this is expensive. So that excavation, we are transporting that material and also placing of replacement material can be expensive. Now time consuming. The process can be time intensive, particularly for large scale projects. The time is important. It is made time being. Environmental impact. Excavation and disposal of soil can environmentally affect. Whatever the weak soil it is there, we are removing and we are dumping somewhere. The process is environmentally, it is going to impact, including disturbances to the site and potential contamination. Limited applicability, not suitable for deep soil improvement or areas with limited access for the excavation equipment. So it is going, these are the disadvantages which we face for this soil reinforcement. Now discuss the principles, advantages and typical application of vibroflotation as a mechanical ground method. Vibroflotation is also known as vibrocompaction. It is a mechanical ground modification technique that uses a vibrate probe to density, loose and granular soils. Previously, same like dynamic compaction. The technique is different where we are using density and granular soil. What is the process? What it improves? It improves density, stability, making it suitable for supporting structural loads. What are the principles involved of this vibrocompaction? Insertion of the vibrator, compaction process, quality control. These are the process. So vibrating probe, a cylindrical vibrator. What is the process involved in this? We are writing typically 2 to 3 meters. We have to mention. Long is inserted into the ground using a crane. Now vibration, the probe vibrates horizontally and vertically, causing soil particles to rearrange and densify. Now compaction process, water or air jetting, step-by-step withdrawal, backfilling. So water or air jets may be used to facilitate probe penetration and enhance the compaction. In step-by-step withdrawal, the vibrator is gradually withdrawn in stages, compacting the soil at each depth. In backfilling, granular material may be added to fill voids and enhance compaction. Quality control, field test, perform tests such as standard penetration test or cone penetration test before and after compaction to assess improvements in soil properties. Monitoring, monitor the compaction process to ensure the uniformity and effectiveness. It is depend, we are the same process we are following. What are the advantages? Effective, where it is effective in granular soils, deep compaction, cost effective, rapid improvement. These are the advantages. So highly effective in densifying loose granular soils such as sands and granulars. Like that we have to mention. Whether any kind we have to mention, it is suitable for which type. Deep compaction, capable of compacting soils to significant depths. Relatively low cost method for improving large areas of the soil. and also it achieves the significant soil improvement in short period. Now, what are the application? Foundation support, liquefaction mitigation, land reclamation, transportation. Like the what are the where we are applying in depth we are going to write about where industrial facilities and also soil liquefaction in earthquake prone areas, stabilizing, so improving soil for roadways, railways and airport runways. Like that we are mentioning where we are applying that particular technique. So like that we are understanding the question and we are applying the step-by-step procedure based on the question. So we will see third module question banks how we write in our next class. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.